So here we have a quick little data set, and this is going to be the students, the amount of hours they studied, and the exam score. And let's just go ahead and mark these off just so we know what our x variables are, what our y variables are. And when you're doing regression, you're going to have a response variable. So we'll call this our x because we want to know how many hours studied will yield a certain exam score, which is going to be our dependent variable. And this just makes it easier for us to work with. So we're going to have one y, but we can have, in this particular example, we're going to have one x. So the first thing we want to do is we find out how strong the correlation is between these two items. Now, we can do this one of actually three ways. We can do it through an Excel function. We can use a Pearson correlation matrix, or we can just go ahead and put in the regression table, and it will give us the value there. So we'll do all three here just so you can see an example of each. So we'll start with the equals CORR, and that's going to be the built-in function, and what it's just asking for the two array values. So you can put them in any order. I choose to always do x first, put a comma, and then put in your y variable, which is going to be your dependent variable, and that's what you're trying to predict. And it's going to give you a score of 0.62. Again, it's always going to be done as a percentage, so you can multiply that by 100, and it's going to be 62.7%. Now, another way to do this is to actually go to the File, Options, and you're just going to turn on your data Toolpak. That's all we're going to do here. I'm going to go to Add-ins, Excel Add-ins, go, and you'll turn on the Analysis Toolpak. And what that's going to do is go ahead and add this extra tab right over here. This is Data Analysis Toolpak, and we'll just click on that real quickly. And we're going to go to Correlation. And again, this is going to be the Pearson correlation matrix, and it just wants to know the input range. So we're going to go select everything here. So as you can see, we selected everything, and we're putting the labels are in the first row just so I can label everything out. And we're going to change our output range, and we're going to put it right here in the sheet underneath, and hit OK. And let's just highlight these real quick and make them a little bit bigger. Cool. And now you can see the Pearson correlation matrix, and as you can see, we got the same exact number. We have 0.6277, 62.77. Again, these are all multiplied by 100, so that's why the value looks different. So this is a good way if you have multiple x values, multiple things that could have factors in predicting the y, to see exactly how strong that correlation is. And 62 is not bad. I mean, it's not great, but it's not bad. And then the final way to do it again is going to the Data Analysis Toolpak, and you want to go down to Regression. And we're going to click here. And now it's going to ask us for our y range. So our y is going to be right here. That's going to be the exam scores. And the x is going to be this right here, which is going to be the hours studied. This again has labels in there, and we'll put this in the same worksheet just so we can view it a lot easier instead of having to go back and forth. And the only thing we want are the residuals. Okay, and we'll click OK, and we don't really need it, but we'll put it in there, and that'll just give us the residual output, which we can use later. But now, as you can see, we have this right here, and our multiple R is actually our Pearson correlation, which is found here, which is our regular correlation. So as you can see, these numbers will all yield the same amount. And next we'll get into the R square value and other things like that. But just to begin, this is where we're going to start with the correlation matrix. And we see that 62 is a pretty high number, so we know that there's a 62% correlation in there, and we'll see what that means in a minute.